Alright guys, so we're going to start reviewing for our third test and extra help is after school on Thursday, October 24th. So for number one, we have one of those laws of exponents questions that have always been coming up, right? There's been one on every single test. So for number one, everything in that numerator is being raised to the second power, so except for the 5. So I am going to write 5 times 2 to the negative second. And then we have x to the positive 14th, y to the positive 6th, divided by 7x to the 18th, y to the negative 4th. So now I'm going to circle anything that's being raised to a negative exponent. So I have this 2 to the negative 2nd in the numerator, and this y to the negative 4th in the denominator. So what's going to happen is I'm going to rewrite everything. So 5 is going to stay on the top, x to the 14th, y to the 6th, divided by 7x to the 18th. So now what's going to happen is this 2 to the negative second in the numerator is going to come down. I'm going to put it out front because it's going to be just really a coefficient. And then y to the negative 4th comes up here to be y to the positive 4th. So then my final answer for this, once I combine everything, first of all, for the coefficients, 2 squared is 4 times 7 gives me 28. So this is going to be 5 over 28. And then x to the 14th divided by x to the 18th is x to the 14th in the x to the 4th, in the denominator. X to the 4th in the denominator. And then y to the 6th times y to the 4th becomes y to the 10th in the numerator for number 1. There's nothing else I can do. That is my final answer to number 1. Numbers 2 and 3 want you to find the inverse. 2 rules for the inverse. Switch x and y and then solve for y. So remember, f of x is really y. So this is now x equals y plus 7 squared minus 15. So to solve for y, I am not going to double distribute the y plus 7. It's much easier for me to take the square root once I get that negative 15 out of the way. So this is x plus 15 equals y plus 7 squared. So now I'm going to take the square root to get rid of that squared. Now, normally, I would have to write plus and minus, but because I'm looking for the inverse function, I'm not going to put the plus and minus. I know it's a little weird. So right now I have the square root of x plus 15 equals y plus 7. So then I would just subtract 7. I'm going to put it out front though. So y equals negative 7 plus the square root of x plus 15. And then I'm just going to write it in the correct notation. So this is my final answer. Negative 7 plus the square root of x plus 15. For number 3, so this is another inverse question, but this one's much more difficult because this is what's called a rational function. So it's more, there's a little bit more involved for this. So for number 3, again, your first steps though are to switch x and y and solve for y. So this is now x equals 4y minus 3 divided by y plus 5. Now, if you remember in class, I told you that all of these steps are all the same. So even though this is a difficult type of inverse, every single time it's the exact same steps. So I'm going to put the x over 1. And then I cross multiply, so 4y minus 3 equals xy plus 5x. So now I'm going to bring all of my y's to one side, anything without a y to the other. So I'm going to subtract this xy over here, and I'm going to get rid of the 3 on this side and add it to the other side. So now I'm here. So all I did was rearrange things in a way that I want, because now on the left side I could take out a GCF of y and I'm left with just 4 minus x. To get y by itself now, I would just divide by that 4 minus x. So this cancels over here, so I would get y equals, but I'm going to write the correct notation. And I get 5x plus 3 over 4 minus x. Now remember, you might have something that's a little bit different, but it could be the same. Number 4, using the discriminant to describe the nature of the roots. So the discriminant is part of the quadratic formula. The discriminant is b squared minus 4ac. Now, b squared minus 4ac, the discriminant, it tells me what my roots are supposed to look like. It doesn't tell me what they are, but it tells me whether my answers are going to be real or imaginary, rational or irrational, equal or unequal. So I have to plug in, once I set this equal to 0, so this is x squared minus 6x plus 9 equals 0. Make sure it's in the correct order too. So when I do b squared here, so negative 6 squared minus 4 times a is 1 times c is 9. That ends up giving me 0 when I type that into the calculator. So my discriminant is equal to 0. When my discriminant is 0, my solutions are real, right? Because it's not negative. When it's negative, when your discriminant is negative, then your solutions are imaginary. If not, then they're real. They are rational, because if you were to take the square root of 0, you would get just 0. There's no radical left over. And then they are also equal, because if you add and subtract 0 to something, you end up getting the same number. So that's all that number 4 wanted. For number 5, same idea. You're going to use the discriminant, but this is a little bit different. This is a little bit trickier of a question. Find the values of k such that the equation has imaginary roots. So we have imaginary roots when the discriminant, when b squared minus 4ac is negative, and you write negative as being less than 0 in an equation. This is actually an inequality. So b squared minus 4 times a times c is k. We want to know, when is that less than 0? When is that negative? So this is 64 minus 16k less than 0. You're going to subtract the 64 over, I'm sorry. So less than negative 64. And then when you divide by negative 16, remember this is an inequality. Whenever you divide by a negative, the inequality switches sides. So now this is going to be k is greater than negative 64 divided by negative 16 gives me positive 4. So k is greater than 4. So anything where k is larger than 4, if you were to plug in and do the discriminant, you're going to get a negative, which means that your solution would have, that means your equation would have imaginary solutions. For numbers 6 and 7, we are writing the equation given the roots. So you have to remember that if you have imaginaries or if you have irrationals, meaning the radicals, you have what's called conjugates. So the sign in the middle changes. So for example, in number 6, you actually have 4 roots. You have x equals negative 2. You have x equals 0. I'm going to put that one first. X equals 0, x equals negative 2. And if you have x equals 4i, you also have x equals negative 4i. So I'm going to set each of these equal to 0. So this one's already done. So x equals 0. This one gives me x plus 2 equals 0. This one is x minus 4i equals 0. And this one is x plus 4i equals 0. So now I'm going to take each piece here, and I'm going to multiply them. So this is going to be x times x plus 2 times x minus 4i times x plus 4i. Now remember, I told you to multiply the conjugates together. So I'm going to multiply these two together first, and I guess I can multiply these two at the same time. So when I multiply the first two together, this one's nice and easy. I get x squared plus 2x. When I multiply the second set, I get x squared plus 4xi minus 4xi, and then minus 16i squared. So remember, whenever you multiply the conjugates, the imaginary number is going to go away. And the reason why is because your middle term, right, 4xi minus 4xi, these are going to cancel out to be 0. And then negative 16i squared, I squared is negative 1. So negative 16 times negative 1 actually gives me a positive 16 over here. So this is really x squared plus 16. This one stays the same, x squared plus 2x. And when I multiply this out, I get x to the 4th plus 2x to the 3rd plus 16x squared, and then plus 32 plus 32x. And the question wants you to call that f of x, so I have to write f of x equals. If you do not write an equation meaning that there's no equal sign, there's no f of x or equals 0 or whatever you want to call it. Here I have to call it f of x. You will lose points on your test if this is a question. For the next one, so I'm gonna erase this. So pause the video if you still need this, but I'm gonna erase this because it took up too much space. Okay, for number 7, it's the same idea. So if you have, remember this comma is separating your roots. So if you have x equals 5 and x equals 7 plus the square root of 2, you also have to have, because this is an irrational solution, you have to have 7 minus the square root of 2 as well. So you're going to set each of these equal to 0. So x minus 5 equals 0. X minus 7 minus the square root of 2 equals 0. And x minus 7 plus the square root of 2 equals 0. I have found that if people try to jump straight from here to here, you make a lot of mistakes with these ones. Okay, so just be careful. So I'm going to take these three things and I'm going to multiply them. Remember, your brain can only do 2 things at once when you multiply them. So x minus 7 minus the square root of 2. X minus 7 plus the square root of 2. I'm going to multiply the conjugates together. Okay, so this gets a little messy, but it's going to clean up nice because, again, the conjugates are going to cancel the things out that we don't want. So this gives me x squared minus 7x plus x square root 2. Then I have minus 7x plus 49 minus 7 square root 2. Then I have minus x square root 2 plus 7 square root 2 and negative square root of 4 or just negative 2. So now when I go to combine like terms on this, I get x squared, negative 7x and negative 7x do not cancel. That becomes negative 14x. Be careful with that. X square root 2 minus x square root 2 cancel. You have 49 minus 2 gives you 47. And then negative 7 square root 2, positive 7 square root 2 cancel out. So again, when you multiply the conjugates, you should get the irrationals to go away. If they do not go away, if you are stuck with radicals, you either did not multiply the conjugates together or you did not multiply the conjugates together correctly. So be careful. And you still have to multiply in this x minus 5. So here I just multiply these two together and my final answer, I'm not going to actually go through the whole thing, but your final answer should be f of x equals x to the third minus 19x squared plus 117x minus 235. And that comes from distributing everything out and then combining like terms. 8 and 9, determine the equation of the parabola in vertex form equidistant to the point in the line. Vertex form, that is x minus h squared equals 4p y minus k. Don't worry so much about the horizontal parabolas. That was just a little extra stuff. So for number 8, the focus is negative 7, 5. I always want you to draw these out. I may not give you a graph on your test. If you want to come with graph paper, you can, or you can just sketch it out like how I'm about to right now. So negative 7, 5, that is going to be 1, 2, 3, 4, 5, 6, 7 this way, 1, 2, 3, 4, 5 up here. And then y equals 3 is right here. That is a horizontal line. In order to plug things into the vertex form, I need the vertex and I need the p-value. So the vertex, that's your h comma k. So here it's going to be right in the middle. So that point is going to be negative 7, 4. When you graph it, you can see what point is in the middle. And then the p-value, this is going to be concave up, because if your arrows go through the directrix, you went the wrong way. So it's going to be concave up, which means p is going to be positive, and we are going up 1 to get from the vertex to the focus. So p is a positive 1. So my equation is x plus 7 squared equals 4 times p. So if p is 1, 4p is equal to 4. So equals 4 y minus 4. So for number 9, we have 2 comma negative 10 as the focus, and then the directrix is y equals 0. So 2 negative 10, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all the way down here. That's your focus. The directrix is y equals 0. So that line is up here. So if I count in the middle, there's 10 spaces, so halfway will be 5. So that point will actually be 1, 2, 3, 4, 5 right about here. The vertex is positive 2, positive 2, comma, negative 5. It is going to be concave down because the parabola looks like it's going to hug the focus. It's going around it. And then that means if it's concave down, that P is negative. So P, from vertex to focus, you are going down 5. So P is negative 5, which means that 4P is negative 20. And that's what gets plugged into your equation. So your answer to number 9 should be x minus 2 squared equals negative 20, y plus 5. For number 10, determine the point and the line equidistant to the following parabolas. So I want to find the point and the line. That is the focus and the directrix. So again, you need to figure out what is the vertex, what is P equal to, and then graph it. So the vertex here is going to be positive 1, negative 2. The p-value for p is equal to negative 12, which means that p is equal to negative 3. So this parabola is going to be concave down because p is negative. So if I go to graph this, 1 comma negative 2 is right here, and it is concave down. Your steps, you are going to go down 3 to get to the focus. So I go down 1, 2, 3. This point is 1 comma negative 5. So the focus is 1, negative 5. And then the directrix, I'm going to go 3 in the opposite direction. So I'm here, so then I head up 1, 2, 3. That line right here, that line is y equals 1, positive 1. So this is my answer. The focus is 1, negative 5, and then the directrix is y equals 1. But remember, this is flipped around. The vertex for this is positive 8, comma, positive 8. So 8, comma 8. 4p is equal to 8, so p is equal to 2. So this parabola is going to be concave up. So when I draw this, one, two, three. I am right here at 8, comma 8. That's the vertex. We are concave up because p is positive. So I'm going to go up 2 because p is 2. That will give me the focus. So right there, that is the focus. That focus is 8, comma 10. We went up 2 from 8, comma 8. And then for the directrix, I'm going to go down 2. But remember, it is a line. So that line is right here. That line is at y equals 6 for the directrix. Again, draw it out. It makes it so much easier if you just draw it out. Number 12 and 13, determine the equation of the parabola in its vertex form given its standard form. So once you find the equation, you don't have to do anything with that. So the method you're going to use for this to go from standard form to vertex form, right, which lets you see the min and the max from the equation, right, because the vertex is really the min or the max, you are going to use completing the square. So I am going to bring my x's and anything without to separate sides. So now I have 12y minus 4 equals x squared minus 8x. Now I'm actually going to flip this around because I don't like having the x's on the right side. I want to have it on the left side. That way it matches that x minus h squared equals 4p, y minus k. So all I'm doing, I'm just switching sides. So x squared minus 8x equals 12y minus 4. right? X equals 3 is the same thing as 3 equals x. So now my a value is a 1, so I can go right into completing the square. So this is x minus 4 squared, right? Half it. Now square it. Negative 4 squared gives me a 16, and I'm going to add that back. So on the right side I have 12y, and then negative 4 plus 16 is a plus 12. Now again though, I need to have a 4p. So I'm going to divide by whatever the coefficient in front of 12 is, and I'm going to pull that out. In front of y is, which is a 12. I'm going to pull that out. So equals, the 12 comes out. 12y divided by 12 is 1y. So I'm supposed to get 1y. If I get anything else, something is wrong. And then 12 divided by 12 is 1. Over here I have x minus 4 squared. All right, so standard form is up here. Well, not really, because you would solve out for y. But vertex form allows you to see what the min or the max is. So this equation, this is concave up because p is positive. P would be a positive 3. So this would have a minimum, and then that minimum would be the vertex, which is 4, negative 1. Okay, but again, it just wanted you to find the equation. For number 13, I am going to bring the x's to the left side and the y's to the other. So I'm going to add over, actually, you know what? I'm just going to subtract the 2 over for now because I want to make sure that you see something in here. So if I subtract the 2, so y minus 2 equals negative x squared minus 4x. Now again, I want the x's on the left side, so I'm just going to switch sides. So negative x squared minus 4x equals y minus 2. Now again, your a value has to be a 1, positive 1. So I'm going to divide by negative 1, everything by negative 1. That way now, negative 1x squared divided by negative 1 is a positive x squared. And we have plus 4x equals negative 1y plus 2. So now I can go into completing the square, half it, square it, and then you're just going to add it back. So we have plus 4, right? 2 squared is 4, plus 4 over here, plus 4 over here. So when I add it back over here, negative y plus 6. Now again, I need to pull out a 4p, so I pull out whatever the coefficient is in front of y. In this case, it's a negative 1. So 4p is going to be negative 1, and then I'm left with y minus 6 over here, and this is x plus 2 squared. So that's my final answer, just additional. If 4p is negative 1, then it's going to be concave down because it's negative, which means that you have a maximum at negative 2, positive 6. And now we just have these word problems. So number 14, the width of a rectangular prism is that, and the length is that. The perimeter is 64. Find the dimensions. So the way that we find perimeter, right, it would be 2 times the length plus 2 times the width, and that's equal to the perimeter. So if I plug in, right, I'm going to zoom in a little bit, so look at your question if you need. So 2 times the length is this, the length is this x squared minus 9x minus 11, plus 2 times the width is x squared minus x minus 5, equals the perimeter is 64. Ladies and gentlemen, this is just another quadratic equation. So I'm going to distribute the 2. So 2x squared minus 18x minus 22 plus 2x squared minus 2x minus 10 equals 64. I'm going to combine like terms on the left side. So that gives me 4x squared minus 20x minus 32 equals 64. And then I am going to subtract over the 64 because I want to set it equal to 0. So 4x squared minus 20x, and then this is now minus 96 equals 0. I'm actually going to do completing the square on this because all of my numbers are divisible by 4. So if I divide everything by 4, I get x squared minus 5x minus 24 equals 0. I lied. I'm not going to do complete in the square. I'm going to factor it. So now I need two numbers that multiply to be negative 24, but add to be a negative 5. This is x squared minus 8x plus 3x minus 24. So x times x minus 8 plus 3 times x minus 8. X minus 8 times x plus 3 equals 0. I set up my equation, so x minus 8 equals 0. Gives me x equals 8. X plus 3 equals 0. Gives me x equals negative 3. Now I'm not done though, because the question wanted the dimensions of the garden. It doesn't want you to solve for x. It wants the dimensions. So I have to see when x is 8, what are the dimensions? When x is negative 3, what are the dimensions? So if x equals 8, I'm going to do this over here. If x equals 8, the length would be, again, the length is x squared minus 9x minus 11. So x squared minus 9x minus 11. That would give me that the length would be equal to negative 19. Now, that's a problem. You cannot have a negative length, right? So that means x cannot be equal to 8, because if x is 8, then your length is negative, and you cannot have a negative distance. In case you did the width first, it would be 8 squared minus 8 minus 5, which would give you 51. So that would be okay, but the negative 19 gets rid of my x equals 8. So that means that x equals negative 3 should work. So if x equals negative 3, then the length would be negative 3 squared minus 9 times negative 3 minus 11. So then that length would be 25. Now if x is negative 3, the width would be negative 3 squared minus negative 3 minus 5, which gives me a 7. So my dimensions are 25 inches for the length by 7 inches for the width. So if you want, you can write length is 25, width is 7. And then if you add up 25 plus 25 plus 7 plus 7, you do in fact get 64. For number 15, a rocket is launched from a hill 80 feet above a lake. So if this is the hill, right, so you're shooting it off of a hill into a lake, right? The rocket will fall into the length after it is launched. The rocket's height above the surface is given by h of t. T is time in seconds after the rocket is launched. So what is the height of the rocket after 1.5 seconds? So h of t gives you the height. Does it tell you? And it's going to be in feet because it says 80 feet above a length. So yeah, we're just going to say it's feet for now. So for number 1, again, the input is the time and the output is the height. So we want to know what is the height of the rocket after 1.5 seconds. I need to do h of 1.5. If I plug in 1.5 for t, I would do negative 16 times 1.5 squared plus 64 times 1.5 plus 80. I type that whole thing in the calculator, and it tells me that after 1.5 seconds, the rocket is 140 feet in the air. Second question, what is the maximum height reached by the rocket? So the maximum height, you are going to find, right, the maximum is the vertex of the parabola. So you have to put this equation into its vertex form. So this is for the second part. So we're going to say y equals negative 16t squared plus 64t plus 80. We're going to put this in vertex form. Ready? So we are going to do y minus 80 equals negative 16t squared plus 64t. I'm going to switch the sides. Negative 16t squared plus 64t equals y minus 80. And now I need my a value to be a 1, and it's not. And it's not. It's a negative 16 right now. So I'm going to divide everything by negative 16. So now I have t squared minus 4t equals negative 1 over 16y plus 5. So now I can do half it, square it, add it back. So I have negative 1 over 16y plus 9. So now for this, though, I need to pull out the a value. I need to pull out, the 4p value. So I'm going to divide by negative 1 over 16 on both of these. So that gives me now t minus 2 squared equals that negative 1 over 16 comes out as the 4p value. And I am left with y minus, if you do 9 divided by negative 1 over 16 in your calculator, you get 144. So that tells me that for this parabola, the maximum is 2, 144. So what that means is after 2 seconds have passed, it's 144 feet in the air. So this question, what is the maximum height reached by the rocket? The maximum height is 144 feet. Okay, and now this last question, this is a lot in here. This last question, after how many seconds after it is launched will the rocket hit the lake? If you need to pause the video because I'm going to erase this, what I have in number 15 so far, so I have room for this question. Okay, so for this question, what I have to do, the rocket will hit the lake. We want to know after how many seconds, right? So we need to solve for t, which means we need to plug something in for the y value, or for h of t, which is the height. So think of that. If you are the rocket, you're hitting the lake, what is the height? That height is at 0, right? So we just had this equation written down. It was it was t minus 2 squared equals negative 1 over 16 y minus 144. So this is when y equals 0. So I'm solving for when y equals 0. So I'm going to plug in 0 for y. So now I have t, do not double distribute this because it's already set up for you to just finish out completing the square. So negative 1 over 16 times 0 minus 144 gives me 9. So now when I take the square root, I get t minus 2 equals plus and minus 3. So t is equal to 2 plus and minus 3. So that gives me t equals 5 and t equals negative 1. You cannot have a negative time, so it's going to hit the lake. This point right here is 5, 0. So 5 seconds have passed, and the height of the rocket is at 0, so that's when it's in the water. And then this last one here. When a ball is thrown into the air, the path that the ball travels is modeled by that parabola. So this question, it already gives you the vertex form, so that's actually kind of nice for us. So I'm going to go ahead, though, and switch this around. So x minus 18 squared equals 4p is messy, but that's okay. Y minus 10. So a ball is thrown into the air, so that looks like this, right? Determine the maximum height that the ball reaches. The maximum height, that's right, this point right here, also known as the vertex. That vertex is 18, 10. So in this question, everything is in feet, right? So what happens is this is the horizontal distance. So this is how far the ball goes, and this is how high the ball goes. The y value is how high, the x value is how far. So 18, 10, so that means after 18 feet, it is 10, once it travels 18 feet forward, it's at its highest point, which is at 10 feet in the air. So determine the maximum height of the ball. The height is the y value, so the maximum height is 10 feet in the air. The second question, determine how far the ball travels before it hits the ground. So how far it travels, so that's the horizontal distance, right? How far it goes, that's horizontally, how far does it go? So you're solving for x when it hits the ground. So that means you have to plug something in for y if you're solving for x. So the ground, the height of the ground is 0. So y equals 0. So again, I'm going to do this. X minus 18 squared equals negative 162 over 5 times 0 minus 10. So this is x minus 18 squared equals, when I plug in negative 162 over 5 times negative 10, that gives me 324. So I take the square root. So x minus 18 equals, the square root of 324 is actually a perfect square. You get positive and negative 18. So x equals 18 plus and minus 18. That is x equals 0 and x equals 36. So when x is 36, meaning it'll travel 36 feet before it hits the ground. Right? So the farthest it will go is 36 feet for the second part. Okay? Extra help is on Thursday after school if you have any questions. Have a good day.